Hello from West Virginia, or someplace, I don't know. But what I do know is joke of the day, and I know you're ready for it. So, an invisible man marries an invisible woman, and you know their kids are nothing to look at either. But what we are going to look at is graphing linear inequalities in two variables. So notice that I've got a linear inequality here, linear because each of the variables is to the first power, and notice that it is in two variables. In order to graph it, I have two things I need to do. One is to graph the line that is represented by this if it was an equation. So in other words, if I change this up and called it y equals 3x minus 4, then I would be able to graph that line. So that is the first step that I'm going to do whenever I graph a linear inequality. Notice the directions in the example say do just that, graph the inequality in a rectangular coordinate system. So when I write it in this way, in order to graph it, notice that that is in that slope-intercept form. The y is by itself, and when you're in slope-intercept form, your slope is sitting right there in front of that x. And remember, this y-intercept right here is a very handy piece of information because this tells me where the graph is going to cross the y-axis. Now, I always like to put it in coordinate form. I always require my students to put it in coordinate form because it's very important that you know where the 0 goes in this coordinate form. This being a y-intercept crossing this y-axis, every point on this axis has no left or right movement at all. Left or right movement is represented by the x. So the x will be 0, the y will be a -4. Now remember, this slope is rise over run. Being a fraction, that means I'm going to take this 3 and I'm going to put it over a 1. Now I have rise over run. It's a wonderful counting tool, but I have to have a place to count from. So I'm going to start with my y-intercept of -4, 1, 2, 3, 4, sitting right here. And now I'm going to utilize my rise over run, meaning from here I'm going to come up, because that's positive, 1, 2, 3. I'm going to go to the right because that's positive 1. And that gives me my second point. Now, I have graphed the line. I'm ready to connect it, but I have to be careful because I'm dealing with inequality symbols here. When my inequality symbols have no equal to part, then think back to when we were doing inequalities on a single number line. And when we had that single number line, and we were looking at that and we were saying, was this point a part of the solution? Now in some instances we would put an open circle, in some instances we would put a parentheses, but I'm not going to put open circle or parentheses on this, but do notice it's a similar idea that with the no equal to part, then that means no, anything on this line is not going to be a solution. In order to represent that, what I'm going to do is I'm going to give it a dotted line. Dotted line is the equivalent of open circles. So as I connect these two, I'm going to connect them with a dotted line like this. And remember, like I said, what that means is everything on this line is not a solution. If there was an equal to part, and that would mean everything on the line is a solution, then rather than a dotted line, I would put a solid line on that. So solid line means it is a part of the solution. That's the equivalent of closed circles or a bracket. And a dotted line represents that no, it's not a part of the solution. It's the equivalent of open circles or a parentheses. So I have graphed my line. However, what we need to understand is because we have an inequality here, that means that everything that works, everything that creates truth, could sit over here or it could sit down here. Notice that the line has created half planes, two half planes. I got a half plane up here and I got a half plane down here. Now, to figure out where all the solutions are, the easiest thing to do is to test a point that's in one of those half planes. In other words, pick a point that's over here. Take its coordinates, plug it in here, and see if it creates truth. And in the previous video, we said, okay, if you plug that coordinates in and it creates truth, then yes, that point is a solution to the inequality. And if it's a solution, that means I'm going to dot it to say it's a solution. But then, if I pick something else over here, if this did work and I pick something else over here, it's going to work as well. So basically, I'm going to dot everything over here, and rather than dot, 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 I'm just going to shade the whole side. Now, on the flip side, if that point that I pick and I plug it in here does not create a true statement, in other words, it creates a false statement, that's not okay. that means that the point that I chose is not a solution to the inequality. So if I pick a point over here and I plug it in and it creates a false statement, that point's not a solution. And what that means is if I pick another point over on this side and plug it in, it as well will not create truth. And it will not be a solution. And everything over here will not create truth and not be solutions. So what will happen is everything on the other side will create truth. So all the solutions will be on the other side and you'll shade that other side. So true statement, you're going to shade that side, but false statement, you're going to shade the other side. Now, when you're choosing your points, it does not matter which point you choose. So guys, make your life easy. Pick a point that's easy to work with. What's the easiest point to work with? Yeah, 0, 0. The origin right here is the easiest point to work with because watch what happens. Now, you cannot choose 0, 0 if it's on the line. That won't work. So if 0, 0 is off the line, in other words, it's in one of those half planes, use it because that is the easiest thing to do. Now, my 0, 0 right here, my origin, is it on the line? No, it's not. So I can use it. So I'm going to test that 0, 0 and watch what happens here. I'm going to put a 0 here where the y is. I'm going to put a 0 there where the x is. I'm going to follow that order of operations, which says multiply here first and then subtract, and I'm going to get 0 less than -4. In other words, 0 is smaller than -4. Well, is that true? No, 0 is bigger than -4. So this is a false statement. So what that means is this point does not create truth. That means everything else over here does not create truth. That means everything over here will create truth. And to prove that to you, I'm going to pick a point on this side. I'm going to show you that it really does create truth. Let's pick this point right here. This is 2, 4, 5, 0. I'm going to test out that 5, 0. So what happens when I test it, and let's put it right here, test 5, 0. I'm going to put a 0 here where the y is. I'm going to put a 5 where the x is. And I'm going to follow that order of operations. 3 times 5 is 15. 15 minus 4 is 11. Is 0 less than 11? Is 0 smaller than 11? Yes, it is. That is a true statement. And like I said, when it's a true statement, that means, yes, this will work. Which means anything else over here will work. So I'm going to, all these work, all of them. Well, guys, what would be much easier is just for me to shade this entire side. So here's where all the solutions are. Everything over here is a solution to that inequality. Everything over here is not a solution to the inequality. And what about everything on the line? Nope, they're not solutions either because it's a dotted line. So this is how you graph your linear inequalities in two variables. You graph the line, solid if there's an equal to part, dotted if there's not an equal to part, test a point. If you can pick that beloved 0, 0, test it. If you come up with a true statement, shade that side. If you come up with a false statement, shade the other side. So let's play with this a little bit more and try a few more examples just to make sure we're really good at this. Now notice in this one, when I go to graph that line, I could either put it into that slope-intercept form and get the y by itself, or I could use my x and my y-intercepts. In this case, the x and the y-intercepts will be the easiest thing to do because to get that x-intercept, I'm going to make the y 0, and notice that when I make that y 0 and it is completely gone, and what I'm doing here is I'm pretending like that's an equal sign at this point to be able to graph the line. This is gone, and the reason I said x and y-intercepts is going to be the easiest is because 10 is divisible by 2 very easily. I get a 5. And then when I go to test my y-intercept, and I'm going to make the x 0, once again, that's going to be pretty easy because when I put a 0 in here for the x, notice here that term is gone, and I get 5y equals 10, and when I divide by 5, I get a 2. So when you have numbers that will easily divide into that constant that's over there, and you don't get fractions and decimals and mixed numbers and things that are difficult to work with, when you can get a nice even integer, go ahead and use your x and y intercepts. So my x-intercept is the 0.50 because I made the y 0, and that sits 2, 4, 5 right here. And my y-intercept is the 0.02 because I made the x 0. And so 0, 2 sits here. How many points does it take to make a line? 2. I've got 2. I'm ready to make the line. I just need to decide, is it solid or dotted? There's an equal to part here. When there's an equal to part, is it solid or dotted? Yes, it is solid. So I'm going to connect these two with a solid line, praying and praying and praying that it's straight, because man, I have a hard time drawing a straight line. Now, I need to decide which side has all the solutions. So I'm going to test a point. Can I test my beloved 0, 0? Yes, I sure can. I'm going to slide this down here a little bit. So let's test out that 0, 0. Remember, you can test it if it is not sitting on the line. And it's not on the line, it's sitting down here. And 0, 0 is the easiest thing to work with, because I'm going to put a 0 right there where the x is. I'm going to put a 0 right here where the y is. And watch how easy this is. This becomes 0, this becomes 0, and the whole thing becomes 0. Now, is this true or false? 0 greater than or equal to 10. Is 0 bigger than 10? No, it is not. This is false. So that means, like I said before, this is not a solution. Nothing over here is a solution. And we just discussed that means everything over here is a solution. And you can test one of the points up here if you want to verify that, but it's not really necessary. Let's say you wanted to test 2, 2 sitting right here. Well, put a 2 in here. That gives you 4. Put a 2 in here, that gives you 10. 4 and 10 is 14. Is 14 bigger than 10? Yes. So that does prove, sure enough, that side does have all the solutions. All right, let's get us another one that I erased. I apologize for that. We've got a 4x plus y less than 11. Okay. Now, in this one, I could try to get my x and my y intercepts, but notice that 4 will not divide into 11 nicely. 1 will divide into 11 nicely, but 4 will not. So I think my better bet here is perhaps just to try to get that y by itself, put it into that slope-intercept form, and look how easy it is to do that. All I have to do is slide that negative 4x, or slide the 4x over by subtracting it, which will give me a negative 4x plus 11, and that's going to be in that slope-intercept form. The only reason that I changed it to an equal sign is because now I'm working on graphing a line, and lines are represented by equal signs, not inequalities. The inequalities is what allows us to shade a side. So I'm ready to graph this line. It's in slope-intercept form, and because of that I can pull out that slope, which is negative 4 sitting right in front of the x. I can pull out that y-intercept, which is the 11. I'm going to put it in coordinate form so that I know where the 0 goes. And we know that this is a fantastic counting tool, but I have to have a place to count from. So I'm going to start with my y-intercept of 0, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, sitting right here. And now I'm going to utilize that slope of negative 4, and I'm going to make it a fraction, negative 4 over 1. So from here, I'm going to rise negative 4, which means comes down 4. 1, 2, 3, 4. I'm going to run, since it's positive, to the right. There's my second point. There's the 2 points that it takes to make a line. I'm ready to connect. I just need to decide, is it solid or is it dotted? There's no equal to part. So it is dotted. So I'm going to connect these with a dotted line. And now I'm ready to shade a half plane. So I need to figure out which side has all the solutions. I'm going to test a point. Can I test my beloved 0, 0? Yep. It's not sitting on the line. So I can test 0, 0. That means put a 0 right here. And put a 0 right here. And now 4 times 0 is 0. 0 plus 0 is 0. Is this a true statement? It says 0 less than 11. 0 is smaller than 11. Is 0 smaller than 11? Yeah, it sure is. That is a true statement. And remember, when it's true, then the side that that point is on gets shaded, because everything on that side is a solution. So I'm going to shade the entire side. There's where my solutions are. And remember, solutions over here, no solutions up here. How about on the line? Yeah, no, these are not solutions because it's dotted. Up here, solutions up here, solutions not down here. On the line, yes, because that's a solid line. Okay, we've got a couple more to go. Okay, so I've got the same directions in these. I'm going to graph the linear inequality. Notice here that I can divide the 2 into 0 and get a 0. I can divide the 6 into 0 to get the 0. So perhaps I can use my x and my y intercepts. So I'm going to do x-intercept means make the y 0. And when I do, and I make this y 0, I get a 2x minus 6 times 0 equal to 0. Again, I'm turning it into an equal sign so I can graph the equation. So that gives me 2x equals 0. I want to divide both sides by 2. 0 in that numerator means 2. So my x-intercept is going to be the x-coordinate is 0, the y-coordinate is 0. Which means when I go to get that y-intercept and I'm going to make the x 0, and I put a 0 right here, notice what happens. I get a negative 6y equal to 0, and when I divide both sides by a negative 6, once again, when that y is in the numerator, I get a 0, and oh my goodness, which I should have known right here. Because when the x is 0 and the y is 0, that's exactly what I had right there. So my x and my y-intercepts are exactly the same thing. Perhaps I would have been better off to do my slope-intercept. So let's try that out. I'm going to get the y by itself, which means that I'm going to subtract that 2x off, and when I do, I get a negative 6y. Again, I'm making it an equal sign because I'm graphing a line. I'm going to subtract that 2x off, and then I'm going to divide by that negative 6, giving me y equals 1/3 x. That's that slope-intercept form. And remember, in slope-intercept form, this b is my y-intercept. It doesn't look like I'm adding anything, but when doesn't look like I'm adding anything, remember, that means I'm adding a 0. My y-intercept is 0, just like I discovered before. From there, I can utilize my slope, rise 1, run 3. So I'm going to come up 1 to the right 3, landing me right here. I'm ready to connect the line because I've got the 2 points that it takes to make a line. Now, solid or dotted, there's an equal to part. So that means it's solid. And remember, that means everything on the line is going to be a solution. But I also have solutions either up here in this half plane or down here in this half plane. So I keep having to do this. This is so funny. So I'm going to test my point. Now, can I test my beloved 0, 0? Not this time, because 0, 0 is on the line. I'm going to have to pick another one of the points in the half plane. Pick anything you want. I'm going to choose 0, 2. So I'm going to pick 0, 2, and I'm going to put it up here in my inequality. I'm going to make my x 0, I'm going to make my y 2, and then I'm going to follow those order of operations. I'm going to multiply first, and then I'm going to do that subtraction. True or false? Negative 12 bigger than, greater than or equal to 0. Is negative 12 bigger than? No, it's not. That's false. And so when it's false, remember, that means nothing up here works. Everything that works is on the other side. So I'm going to shade this half plane. So all of my solutions are down here, no solutions up here, and everything on the line is a solution. All right, let's try this last one. And that last one was y greater than x. So beauty is this is already in that slope-intercept form. I already have the y by itself. Now that means that slope-intercept is going to look like this. And what is my y-intercept? What is being added but doesn't look like it would be that 0. So my y-intercept is 0 right here. My slope is right in front of that x, so the slope is 1. And remember, if I have to have a fraction rise over 1, then I'm going to put it 1 over 1, meaning I'm going to come up 1, right there. Now, I'm going to connect them to make that line solid or dotted. Dotted, there's no equal to part. So I'm going to connect them with a dotted line, reminding me that nothing on this line will work. Nothing on the line is a solution. Now, I need to test a point to see what does work. Which half plane has all the solutions? Can I test my beloved 0, 0? Nope. It's on the line. So pick something else. Let's pick this over here. This is going to be 4, 0. Give that one a shot. So I'm going to make this 0, and I'm going to make this 4. Is that true? 0 greater than 4, 0 bigger than 4. Nope, that's false. And remember, what that means is nothing over here works. Everything on the other side works. I'm going to shade the other side. Now, folks, it's very coincidental that whatever I chose just happened to be false. That's total coincidence. I thought about picking the 0, 2 again. If I would have done that, then I would have had 0 here, 2 here. 2 is bigger than 0. And I still would have shaded that side. It's just a coincidence. But the point is, everything up here, every one of those coordinates, if you pick any point up here, and you put that point's x-coordinate here and y-coordinate here, it will create truth. But nothing down here works. If you pick any of these points down here, and you take that point's x-coordinate, put it here, and take its y-coordinate and put it there, it's not going to work. It will not create truth. Everything on the line, same thing, doesn't create truth. So I hope that helps you with graphing linear inequalities in two variables, putting them in the 2D coordinate plane because you have two variables. When you only have one variable, you put them on a single number line. But when you throw that second variable in there, you've got your x variable, you got your y variable, that's what creates the 2D coordinate plane. And when you're graphing these inequalities, you have to graph the line, and if you have an equal to part, it's solid. If you don't have an equal to part, it's dotted. Graphing the line goes back to all those methods for graphing lines that we've talked about before. Put it in slope-intercept form. Pull out the slope, pull out the y-intercept, graph that y-intercept, then use the slope as a counting tool. Or use your x and y-intercepts. Throw the 0 in for the y. That will tell you what the x is, giving you your x-intercept. Throw the 0 in for the x. That'll tell you the y, telling you what the y-intercept is. Put those 2 points on the line. It only takes 2 to make a line. So graph that line and then figure out which side, which half plane has all the solutions. And all you have to do is test a point that's in one of the half planes. Pick your beloved 0, 0 if you can. If you can't, pick something else that's in the half plane. When you plug it into the inequality, if it creates a true statement, shade that side because everything there is going to work and create truth. If it doesn't create truth and you get a false statement, shade the other side because nothing on that side will work and everything on the other side will work. I hope that helps. Have a great day.